Hello guys, let's solve count univalue subtrees today. So in this question we are given the root of a binary tree and we simply just need to return the number of univalued subtrees, and they're defining a univalue subtree as a subtree where all the nodes of the subtree including itself have the same value, right? So let's see example 1. So in this example clearly there are 4 univalued subtrees marked in blue, because the nodes themselves and all the nodes within the subtree all have the same value, right? And in the second example it's an empty tree, so we just return 0. And in the last example it's the same as example 1, but instead of 1 here we have a 5. So you can see why the answer is 6, right? All the nodes are now univalued because they all have the value 5. The node has the value 5 and all its subtrees also has the value 5. So all of these nodes are individually univalued subtrees as well. So we return 6, right? So let's see how to solve this problem. So we have a slightly more complex example here so that we can sort of understand the algorithm better. So one obvious observation here is that the leaf nodes are all definitely univalued, right? Because they just have one node and that subtree has just one value, so that is definitely going to be univalued. So it sort of gives you an intuition as to we need to build the solution from the leaf to the root, right? Like the information is there in the leaves and that sort of has to be propagated upwards towards the root, right? So let's first take an example where you want to evaluate a specific node. So how do we know that if this node is univalued or not? So for a node to be univalued, the left subtree must also be univalued, the right subtree should also be univalued, and the value of the left subtree and the right subtree and the node should match, right? So that's how you sort of build the solution from the leaf and propagate it towards the root. So let's try to track the algorithm for the entire root, entire tree, and see how this works. Yeah, so in this example, I've also marked the null nodes because it's sort of important how you process the null nodes as well. So let's recurse through this tree. So you do a typical like a post-order traversal where you first propagate recurse through the left subtree, then the right subtree, and then you sort of evaluate the current node, right? So let's go left, and go left. And then once we reach a null node, we know that there's a null node. So for every node, we return two values, right? One indicating whether it's a subtree, it's a univalue subtree or not, a Boolean value basically, and another indicating the corresponding value for it. So for the null case, we're going to return true followed by a wildcard x. I'm calling it a wildcard because for a null node, it doesn't really matter what the value is. It just matches with all the other values as well. This probably would make more sense once I write down the code. So again, we go down here, it's a null node, and then you return true followed by the wildcard x, right? And now it's time to evaluate 5. So to evaluate a node, we need to check if the left subtree is univalued, the right subtree is univalued, and if the values match. So they are both true, and since we have a wildcard, we know that the values actually match. Like any number would match a wildcard, right? So we know that 5 is definitely univalued. So let's mark that. And once we're done with the node, we need to propagate the information towards its parent. So what would 5 return to 1? So it's going to return a true, indicating that 5 is indeed univalued, along with the value 5, which is the value for this univalued subtree, right? And then from 1 we go right now, and the same thing happens here. They both return true along with the wildcard, and then we know that 5 is univalued, and then 5 would basically now return a true along with the value 5, right? And now it's time to evaluate 1. So we check the left subtree and the right subtree. They are both true, indicating that they are univalued, but the value that is being returned from the left and right are 5, while the value of the node is 1. So since this is not matching, we can immediately say that 1 cannot be a univalued subtree, right? And then now we need to propagate the information back to its parent. Since we know that 1 is not univalued, we can just send a false along with just like a null value. So once we know that it's false, we don't really care about what value this is. It can just be null or whatever, right? And let's recurse down the right subtree. Yeah, so for the right subtree, let's go right, and then we'll go left. And since this is a null node, it's going to return true, followed by the wildcard x. And then we go right again, and then we go left. And then the same process is going to happen. This is going to tell us that 2 is a univalued subtree, and this is going to return a true, followed by 2. And the same thing happens on the right subtree as well. So this is going to return a true, followed by the value true. And now we know that for this particular node, the left subtree and the right subtree, they both have the value true, both have booleans true, and their values are matching. So they're all 2. So that way we know that this node is also a univalued subtree, right? So we can mark them as univalued and basically count them. So when you reach this point, now this 2 would return a true value followed by the value 2 here. And now it's time to evaluate this node, this 2. And now we can see that for this 2, the left boolean is a true, the right boolean is a true. But the value from the left subtree is a wildcard. Value from the right subtree is 2. And the value of the node is 2. So since now we know that why the wildcard makes sense here, because we know that a wildcard matches with any value. So this would return true because all the values sort of match. So we can mark and count this as a univalued subtree as well. And finally we return to the root with the t under the true under 2. And for 5 we can see that the left subtree returned a false, so we can immediately mark this as false, right? So the total number of univalued subtrees was this 2, this 2, this 2, this 2, and then these 2 5s. So that's going to be 4 plus 2 6, right? So hope you got an understanding of how this algorithm works. So let's quickly see how to code this. Yeah, so let's start with first defining the value for the wildcard that I was talking about. So I'm just going to give it a value 2000 because I know that the values of the node ranges from just -1000 to 1000, just to make sure that no node actually has this wildcard value, right? And I'm going to have the result variable defined as an array of one integer. This is just to make sure that when I increment this index inside, increment this value inside the recursive function, there is no problems because of local variable, global variable, issues like that. You could also assign it as a class variable and then increment it inside the function, but I just choose to do it this way, right? So let's define the recursive function. So it's going to take a single argument, which is the node itself. So first let's handle the null case. So we saw that when it's a null value, when it's a null node, we return true followed by the wildcard x, right? So that's how we handle null values. And if it's not null, we basically do like a post order traversal, right? So we're gonna recurse left and right. So we're just gonna do recurse node dot left and recurse node dot right. And they're gonna return a boolean value followed by the boolean variable followed by the value. So it's gonna be left bool, comma left val, and here it's gonna be right bool, comma right val. Right? Now is the time when we need to evaluate the current node, right? So this condition is probably going to be a little big, so I'm just going to split it across a few lines just for clarity. So what was the first condition? That both the left and right subtrees needs to be true, right? So let's first define that. And what was the second condition? The values from the left and right subtree should match the node value, right? So the left value can either be the wildcard value or it should be equal to the node value, right? And I'm going to just do the same thing for the right subtree. The right value needs to be the wildcard value or the node value, right? So all these conditions need to be true for the node to be univalued, right? So if this is all true, I can go ahead and increment the counter, and I can also return a true along with the current value, right? So this is the case when node is a univalued subtree, and in the other case all we have to do is just return false along with any value. Can be just none, because once we know it's a false, we know that it's definitely not a univalued subtree. So that's about it for this the recursive function. Now we just need to kickstart the recursion, just say recurse root, and just return the value inside the result. Right? Let's see if there are not any issues. Looks good. Awesome. So let's quickly see the complexities for this solution. So this is a standard DFS traversal. So the time is going to be just O of n, and we aren't really using any extra space apart from this one variable. So the space is going to be O of 1, right? I felt this was a pretty interesting and unique problem to solve, because you don't typically return two values from a recursive call, which I thought was pretty unique. But yeah, hope you guys understood the solution, and thank you for watching.